Since the 1970s, researchers have dreamed of buildings that consume no energy at all. From early zero-energy prototypes to today's passive houses, the journey has been remarkable. Let's explore how we moved from complex experiments to simple, affordable, and sustainable solutions. 1. Early zero-energy houses, 1970s. The very first zero-energy houses, built in the 1970s, were ambitious but complicated. They relied on advanced technical systems and came with high costs. Over time, researchers found a simpler path: build houses with excellent insulation that don't even need a conventional heating system. This led to the passive house. Passive houses turned out to be reliable, comfortable, user-friendly, and scalable. Meanwhile, the idea of a fully independent, or energy-autarchic house became technically possible, but still far too expensive and questionable in terms of ecological benefit. 2. The low-energy house, LEH. As a compromise, the low-energy house emerged. Instead of eliminating all energy use, it aimed for affordability and practicality. These houses consume less than 70 kilowatt-hours per square meter per year, roughly 2/3 less heating energy than a standard building. Sweden pioneered this approach in the 1980s, and by 1991, the Nybyggnadsregler made it mandatory. Germany's 2010 building code also corresponds to the LEH standard, though many German buildings actually perform better than required. The passive house. The passive house goes further, cutting heating demand down to just 15 kilowatt-hours per square meter per year. This is achieved with exceptional insulation, no thermal bridges, airtight construction, triple-pane low-emissivity glazing, and controlled ventilation with heat recovery. Because heating needs are so low, a separate heating system is unnecessary. Ventilation alone can distribute small amounts of heat. The total primary energy demand, including appliances, lighting, pumps, and hot water, is capped at 120 kilowatt-hours per square meter per year. Training is crucial. Certified passive house designers and trades make this standard possible. Certified products, like windows and prefabricated components, also accelerate adoption. 4. Zero heating houses. The next step is the zero heating house, a building with zero heating demand in an average year. Even on the coldest days, no auxiliary heating is required. One example is the Darmstadt-Kranichstein passive house, where insulated sliding shutters lowered window U values, making it possible to shut off auxiliary heating entirely. These houses rely solely on solar gains and internal heat sources. However, moving from 70 to 15 kilowatt-hours is cost-effective. Pushing from 15 down to 0 is disproportionately expensive, with little ecological benefit. And of course, energy is still needed for hot water, appliances, and ventilation. 5. Energy-autarchic houses. True zero energy. Energy-autarchic houses go a step further. They meet all energy needs on site, without grid connection. An example is the Fraunhofer ISE solar house in Freiburg, which combined solar collectors, photovoltaics, and seasonal hydrogen storage. But these systems require oversized energy generation, massive storage, and high material costs. In practice, they remain impractical where grid connections are available. 6. Grid-coupled plus energy houses. A more realistic path is the plus energy house. These buildings generate renewable energy, feed the surplus into the grid, and draw electricity when needed. Over the year, they produce more than they consume. The grid balances supply and demand, allows for efficient renewable plants like wind or biomass CHP, and makes large-scale storage far more cost-effective than individual home systems. 7. Coupling and climate-neutral settlements. At the settlement level, coupling passive houses with renewable energy generation achieves climate neutrality. For example, the Hanover-Kronsberg passive house neighborhood invested in wind power shares to offset all energy use. Because passive houses consume so little, renewable integration is both technically and economically feasible. And as household appliances become more efficient, the opportunities for renewable coverage only increase. Low-energy houses are becoming the baseline for construction. Passive houses are the optimal solution: cost-effective, comfortable, and scalable. Zero heating houses are possible, but impractical. Energy-autarchic houses remain unrealistic. The best path forward is grid-coupled passive or plus energy houses, combining ultra-low demand with renewable energy integration for a sustainable future.